to say this is a delicate situation. Because we are dealing with infinity, and not many people understand infinity. Most people don't understand infinity. Most mathematicians don't like infinity. It's a so dangerous thing. It's a very dangerous thing, infinity. You really don't have an understanding, a proper understanding of it. It's very non-intuitive, infinity. But that is what you would have to go and read your notebooks if you didn't understand what I said. Okay, I mean your textbook, the integral test. Basically, you're looking at a decreasing function. You're going to set up an improper integral. If your improper integral is finite and your rectangles are underneath, your sequence is finite. If you have an infinite integral and the infinite integral, the improper integral is infinite, and your rectangles are above, your rectangles are infinite. If your rectangles give you the sum of the sequence, then your sequence is infinite. I will do it with this one here. I'm not going to, we know it diverges. So I'm going to look at what function? 1 over x. And I'm going to be shoving my rectangles above or below? Above? Below? Let's try both. Above, because we know it diverges. Yeah, I'm sorry I have to wake you up with this logic at 9 o'clock on a Tuesday morning. Mr. Aldane.
So it's above, the rectangles are going to be above the graph. You're going to say that those rectangles add up to an infinite number. So obviously the curve underneath goes. Yeah? My logic's broken.
The logic is short. I'm sorry, this is hard. I'm going to be shoving rectangles above a curve. I'm going to show that the area under the curve is, Mr. Rapino, I'm going to show that the area under the curve is, that is it. You have to write that down now. I will give you 5 minutes to write that down. You are shoving rectangles above a curve in the hope that the area under the curve is infinite. You are going to be shoving rectangles under the curve in the hope that the area under the curve is finite. That is what you're going to have to do. Or you're going to have to read your textbook and make perfect notes. So, 1 over x, which we know. 1 over r, which we know, diverges. And I'm looking at what function f of x equals 1 over x. I'm not going to show that this is decreasing. Please, when I should calculus 1 friends. Oh, I should pre-calculus, please know something about that function. It's decreasing. Of course, if your function is not decreasing, then you cannot do any logic. Huh? You start putting rectangles there. What are you doing now? Up and down, below, over, below, over. The logic is gone. Washed out. Right, Mr. Collins? Well, sometimes you're above and sometimes you're below. So the area under this is finite. What can you conclude? Nothing. One over 1. 1 over 2. 1 over 3. 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5. That's what I want. Is everyone with me?
Yes.
Now I know that this series converges or diverges. So am I going to do this or this? That one. And what would be that? 1 over 1. that? Copy that. 1 over 2. The height is 1 over 2 and the width is 1. And what is that? 1 over 3. So the area is exactly what I want. 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6. Is exactly what I want. Which is what is the relation that A, B, C, D, none of the above. A, B, C, D, E. A, B, C, D, E. And A, B, C, D, E. I'm trying to establish divergence. I better hope this is bigger than this. Clear. You can see it. This is bigger than this. We may conclude what? We may conclude something only if this is. Huh? Infinite. If this is finite, we may conclude what? Nothing. What is another way to say this? The integral from 1 to infinity of 1 over x dx. That is what I'm saying. I'm going to show that the area under the curve is finite or infinite, so that I may conclude something about the area above it. That is the area under the curve, and the rectangular area is above it. I'm going to only be able to conclude something if that infinite integral is infinite. If that infinite integral is finite, I may conclude nothing. So now it remains for me to do this. And this is what I think you did a couple of weeks ago with improper integrals. I'll take another sheet of paper and work it out. Take another sheet of paper and work it out. What is this? Yes, what is it? Yes, what is it? Please, it's the limit. You will have to go up to A and then let A go to infinity.
Okay.
Please. Okay, I know we did it a couple of weeks ago, but that's the reason why we did it, because we want to do the integral test. That's not- The limit as A approaches infinity of what? Huh?
Integral from 1 to A of 1 over 5.
And what is this? evaluate that? And 1. Okay, come on. As A goes to infinity of ln A minus ln 1. What's ln 1? 0. It's the limit. As A goes to infinity of ln A. And what does ln A go? Which is what Mr. Cole has? Infinity. And this thing says, hey, infinity fellow, I'm bigger than you. That means I'm infinity too. Yes. That is to say, this series is infinite. Quite delicate one. Very delicate. You want to try it? You try it. Here we go.